3.2 billion light-years from Earth, a group of astronomers have captured live with Hubble something they never thought they would get to see.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope, travelling through time and space with our host, Dr. J.
There are many galaxies of different shapes and sizes in the universe around us today. Now, roughly half are gas-poor, elliptical-shaped galaxies with few new stars forming today, whereas the other half are gas-rich, spiral, and irregular-shaped galaxies with lots of new star formation activity. Now, observations have shown that the gas-poor galaxies are most often found near the centers of rich galaxy clusters, whereas the spirals spend most of their life in solitude. However, observations of the deep and very far-away universe have also shown that when the universe was roughly half of its present age, things were very different. Back then, only about 1 in 10 galaxies was a gas-poor one. So the question is, where did all today's gas-poor galaxies come from? Apparently, there must have been some kind of transformation process. But because galaxy evolution takes place over billions of years, astronomers have so far not been able to see it live.
New observations with Hubble by an international team led by Luca Cortesi of Cardiff University, United Kingdom, provide one of the best examples to date of this metamorphosis.
Well, we were looking at the Abell cluster 2657 and we realized that this galaxy was falling into the cluster center at a velocity of approximately 3.5 million km per hour.
Abell 2667's enormous gravitational field is generated by the combined contribution of the cluster's dark matter, hot gas, and hundreds of galaxies.
As the galaxy plows through the cluster, its gas and stars are being stripped away by the hot plasma in the cluster, which can reach temperatures as high as 10 to 100 million degrees. Also contributing to this destructive process are the tidal forces exerted by the cluster. These are just like the tidal forces of the Moon and Sun, which push and pull the Earth's oceans.
Both processes, the tidal forces and the aptly named ram pressure stripping, resulting from the action of the hot cluster gas, resemble those affecting comets in our solar system. For this reason, scientists have nicknamed this peculiar spiral with its tail the Comet Galaxy.
We see a unique galaxy that is being transformed by the fact that it's falling toward the cluster center. And what we see exactly, it's a kind of a spiral galaxy with lots of gas. And we see a trail of stars, of blue-forming stars, and also around those stars some kind of wispy gas stripped away by the fall.
Furthermore, millions of now homeless stars have been snatched away from their mother galaxy, which will lead it to age prematurely. Even though its mass is slightly larger than that of the Milky Way, the spiral will inevitably lose all its gas and dust, and hence its chance of generating new stars later, so it will probably become a gas-poor galaxy left with an old population of red stars.
However, in the midst of all this destruction, the cluster's strong tidal forces have triggered a baby boom of star formation.
Hubble's sharp eyes have caught other spectacular effects of Abell 2667's immense mass. The giant bluish arc seen just off-center is the magnified and distorted image of a distant background galaxy seen through the gravitational lens formed by the tremendous mass concentration of the cluster. At the cluster's center, another rare feature can be seen. The vivid blue light from millions of stars created in a so-called cooling flow. Some of the hot cluster gas is cooling in a filamentary structure as it falls into the cluster's core, setting off the birth of lots of bright blue stars outshining their environment. This may be the clearest picture of this phenomenon yet.
By combining the visible, infrared, and X-ray views from Hubble, Spitzer, Chandra, the VLT, and Keck, we can see that this discovery adds a new brushstroke to a painting where galaxies are being slowly shaped by their violent interactions with the cluster environment. Although there are many discoveries still to come, the emerging elements shed new light on the painting's mysterious nature and are revealing some of its hidden wonders. This is Dr. J signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.
The NASA ESA Hubble Space Telescope celebrates its 17th birthday with one of the largest panoramic images ever taken, the violent stellar fireworks of the Carina Nebula.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liska.
Welcome to the Hubblecast. On the 24th of April, we celebrated Hubble's 17th anniversary in space. In these 17 years of exploring the universe, Hubble has made nearly 800,000 observations of more than 25,000 different celestial objects. It takes pictures of the universe as it hurtles through space, orbiting Earth at a breakneck speed of 28,000 kilometers an hour. Now in 17 years, that makes nearly 100,000 trips around our planet, or a total of 4 billion kilometers. That's one round trip to Saturn. Today we are celebrating Hubble's 17th birthday by releasing a stunning 50 light-year wide image of the tumultuous central region of the Carina Nebula, where a maelstrom of star birth and death is taking place.
In the southern sky, not far from the Southern Cross, we find the constellation Carina, the Keel. Here, 8,000 light-years away, the immense Carina Nebula is located. Hubble's new view of the Carina Nebula shows the process of star birth at a new level of detail. The bizarre landscape of the nebula is sculpted by the action of outflowing winds and scorching ultraviolet radiation from the monster stars that inhabit this inferno. In the center of the nebula, we find Eta Carinae, which is estimated to be 100 times more massive than our Sun. It is in the final stages of its brief eruptive lifespan, as shown by two billowing lobes of gas and dust that presage its forthcoming explosion as a titanic supernova. Eta Carinae was the site of a giant outburst about 150 years ago, when it temporarily became one of the brightest stars in the southern sky. The star remains one of the great mysteries of stellar astronomy.
Looking closer at the nebula, we find a number of very interesting features. Pillars of gas and dust reveal unequivocal evidence that stars are being born inside the columns. Streamers of gas shoot out from the pillars and plow into the surrounding gas like a fire hose hitting a wall of sand. The jets are being launched from newly forming stars hidden inside the columns. Everywhere we find small nuggets of cold molecular hydrogen and dust called Bock globules that are silhouetted against the nebula. Now, the edges are glowing, which indicates that they're being irradiated by the hotter stars around. It's been hypothesized that stars may be forming inside these dusty cocoons.
Since February 2007, Hubble has been operating with a reduced capability after one of its main cameras suffered a short circuit. A fifth servicing mission is, however, planned for September 2008 using NASA's Space Shuttle. 2 new instruments will be installed and several other upgrades will be made.
The Carina Nebula is just one example of what Hubble can do. Every day, Hubble generates 10 gigabytes of data. That makes 30 terabytes over the 17 years of its lifetime. The Hubble archive is a real goldmine to astronomers in Europe and in the US. Every day, 66 gigabytes of data are being downloaded, and absolutely everyone can get access to these riches via the internet. More than 7,000 scientific papers have been published based on Hubble observations, and that makes Hubble one of the most productive scientific instruments ever. This is Dr. J, signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.
เป็นที่รู้กันอยู่แล้วนะคะคุณเนไทยว่าเวลาดวงอาทิตย์เนี่ยสาดแสงแรงๆเนี่ยเราไม่ควรที่จะมองตรงๆนะคะกับดวงอาทิตย์เพราะว่าจะไม่ดีต่อสุขภาพของสายตาค่ะแต่ว่าล่าสุดเนี่ยกล้องพิเศษของ NASA นะคะได้ไปสำรวจดวงอาทิตย์และทำให้เราได้เห็นเกือบจะทุกแง่มุมของดวงอาทิตย์ค่ะและมีบางแง่มุมด้วยที่ทำให้ทฤษฎีที่เราเคยรู้เดิมๆเกี่ยวกับดวงอาทิตย์นั้นต้องเปลี่ยนไปค่ะล่าสุดนะคะ NASA เนี่ยก็ได้ปล่อยภาพของดวงอาทิตย์ค่ะซึ่งเป็นการบันทึกโดยกล้องโทรทัศน์จากยานสังเกตการณ์ที่มีชื่อว่าสุริยะพลวัตนะคะเป็นยานสำรวจดวงอาทิตย์ลำใหม่ล่าสุดค่ะทั้งทันสมัยแล้วก็มีเทคโนโลยีล้ำหน้าอย่างมากค่ะก็ได้ภาพเนี่ยที่สะท้อนให้เห็นนะคะถึงเพลิงสุริยะหรือว่าโซลาร์แฟลร์ค่ะที่มีพลังเนี่ยเทียบเท่ากับระเบิดไฮโดรเจน100ลูกพวยพุ่งออกมาเลยนะคะแล้วก็ยังแสดงให้เห็นถึงวงแหวนแห่งไฟที่มีความร้อนหลาย10ล้านองศาแผ่รัศมีเนี่ยกว้างนับหมื่นกิโลเมตรค่ะมีขนาดใหญ่กว่าโลกมากกว่า100เท่าค่ะถ้าพูดถึงระเบิดไฮโดรเจนเนี่ยนะคะเขาบอกว่ามีอำนาจทำลายยิ่งกว่าระเบิดปรมาณูซะอีกค่ะเพียงลูกเดียวก็สามารถทำลายศูนย์กลางเมืองใหญ่ได้เพราะว่าเป็นระเบิดที่ทำให้เกิดความร้อนตึกถล่มแล้วก็ยังมีรังสีแกมมาที่สามารถฆ่าชีวิตผู้คนได้นับแสนคนค่ะ
ค่ะที่พิเศษมากๆอย่างที่ภาพที่ได้เห็นนะคะก็เพราะว่าหลายภาพเนี่ยที่มาจากยานนี้นะคะแสดงให้เห็นถึงรายละเอียดบนพื้นผิวดวงอาทิตย์ที่เรานั้นมักจะไม่ค่อยได้เห็นกันง่ายนักนะคะและยานสังเกตการณ์ลำนี้นะคะก็เพิ่งจะถูกปล่อยออกสู่ห้วงอวกาศเมื่อช่วงเดือนกุมภาพันธ์ที่ผ่านมานี่เองโดยมีภารกิจนะคะในการสำรวจแล้วก็ถ่ายภาพของดวงอาทิตย์นี้เป็นระยะเวลา5ปีด้วยกันซึ่งนะคะใช้เงินมหาศาล 27,000 กว่าล้านบาทเลยนะคะเพื่อที่จะทำให้นักวิทยาศาสตร์นั้นเข้าใจกระบวนการต่างๆที่เกิดขึ้นบนดวงอาทิตย์มากยิ่งขึ้นและทาง NASA นะคะยังตั้งความหวังว่ายานลำนี้จะช่วยให้นักวิทยาศาสตร์นั้นสามารถศึกษาผลกระทบของเพลิงสุริยะนะคะว่าในอนาคตหากเกิดขึ้นจริงๆเนี่ยจะสร้างความเสียหายให้กับระบบดาวเทียมสื่อสารและอุปกรณ์ไฟฟ้าบนโลกมนุษย์อย่างไรบ้างนะคะเพื่อที่จะเตรียมหามาตรการป้องกันเอาไว้ก่อนหากว่าเกิดสิ่งที่เรียกว่าเพลิงสุริยะขึ้นมาจริงๆในอนาคตค่ะ
Using the NASA ESA Hubble Space Telescope, astronomers have found the first clear evidence of high-altitude haze or clouds in the atmosphere of an extrasolar planet. This discovery reveals a deeper understanding of the class of giant planets that astronomers call hot Jupiters.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liska.
Hello and welcome to the Hubblecast. Over the last 15 years, astronomers have discovered more than 270 planets around other stars. A burning question is naturally, what are these so-called extrasolar planets like? Well, most of them are actually giant gaseous worlds, several times the size of Jupiter, which is our own solar system's largest planet. Others are smaller, rocky or icy worlds that are still several times larger than our own home planet Earth. We have yet to discover a world that is similar to our own planet.
Using the Advanced Camera for Surveys, or ACS, the Hubble Space Telescope has recently observed a fascinating large gaseous planet around the star HD 189733. Careful analysis of these very high-precision observations by a team led by Frédéric Pont from the Geneva University Observatory showed that this planet, designated HD 189733b, possesses a murky haze layer extending over an altitude range of about 1,000 kilometers in the planet's upper atmosphere. The atmosphere of this gaseous planet is at around 800 degrees Celsius. This is due to its proximity to its parent star and is the reason that astronomers call this type of planet a hot Jupiter. These hazes are probably made of tiny condensed particles less than 1,000th of a millimeter across, similar to those already known on Venus and Saturn's moon Titan. Their presence means that the sky over HD 189733b would look very much like a red hazy sunset viewed from an industrially polluted city on Earth.
Today we have a special guest. This is Dr. Bob Fosbury. He's the leader of the European Hubble effort. So tell me, Bob, what's so special about this particular star and its planet?
Well, this is a rather special planetary system because the star itself is quite small. It's only about 75% of the size of our Sun, and yet the planet itself is larger than Jupiter. So when the planet transits in front of the star, it obscures quite a large fraction of light from the star, which enables a very accurate measurement.
So what exactly made these observations so precise? Why was this only possible now?
Well, we have to do this from space because when we try and do this from the ground, the atmosphere makes it very difficult to make precise measurements of brightness. So we do it from space. And the special thing about this particular observation is that the scientists spread the light out over many pixels in the detector. So rather than just having a little point of light representing the star on the detector, the starlight was spread out into a spectrum using this so-called GRISM mode of the Advanced Camera for Surveys. Now, that enables a very precise measurement because you can measure over many, many pixels, a large area of detector. But it also, by spreading out the colors, it enables you to measure the brightness of the reduction in brightness of the starlight over many colors. So, and having these different measurements in different colors enables you to characterize the nature of the atmosphere.
To detect the hazes, astronomers actually had to do quite a bit of detective work. Now the reason why this work was possible at all is because from our vantage point, the orbit of HD 189733b is seen almost exactly edge-on. Now what that means is that every 2 days or so, the planet actually moves across the face of its parent star as seen from here. Now when that happens, some small fraction of the light from the star has to pass through the atmosphere of the planet in front of it in order to reach Earth. Now because of this process, the composition of the atmosphere of the planet is stamped onto the light like a unique fingerprint. Astronomers can then see this fingerprint in the spectrum of the star's light.
The astronomers were expecting to see clear signatures of sodium, potassium and water in the planet's atmosphere. The fact that these were not seen led them to this conclusion that they were being masked by red-coloured high clouds or haze. According to the scientists, the haze probably consists of tiny particles, condensates of iron and silicates.
When extrasolar planets were first discovered about 15 years ago, little did we know how quickly we would begin to unravel their secrets. The new Hubble observations are an important step towards a better understanding of these amazing planets outside our own solar system. Who knows what we will discover in the next few years about these distant worlds? This is Dr. J, signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.
Regarded by many as the most valuable astronomical tool, the Hubble Space Telescope is approaching its 19th anniversary in space. Hubble sees into the far reaches of the universe, but its powerful instruments have also surveyed our planetary neighbours. In this episode, we'll see what Hubble has revealed to us in our own solar backyard.
This is the Hubblecast, news and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J, aka Dr. Joe Liska.
Hello and welcome to another episode of the Hubblecast. Even those who, for some strange reason, aren't astronomy enthusiasts are likely to recognize some of Hubble's most famous images, like the Pillars of Creation in the Eagle Nebula, or the Hubble Deep and Ultra Deep fields, which have shown us some of the most distant galaxies ever observed. The Hubble Space Telescope has really fundamentally changed our understanding of the universe at large. But with its high-resolution images of planets and moons in our own solar system, it has also taught us a lot about our own cosmic neighborhood.
Hubble cannot observe our Sun, or the closest planet, Mercury, because its instruments are light-sensitive and would be damaged. However, the telescope has examined every other planet in the solar system, including dwarf planets, Pluto, Ceres, and Eris. But of course, Hubble does not just produce pretty pictures. It provides planetary scientists with vital information about our neighbours that may help us better understand our own home planet, Earth.
The innermost planet in our solar system that Hubble has studied is Venus. In a sense, Hubble has acted as some kind of interplanetary weather satellite to study Venus's climate. Now, the observations have shown that the atmosphere of Venus is continuing to recover from an intense bout of sulfuric acid rain, which was probably triggered by the suspected eruption of a volcano in the late 1970s.
On Mars, the red planet, Hubble has been useful in tracking dust storms, a common Martian phenomenon that can envelop the entire planet. Since Mars is a hub of spacecraft activity, including both orbiters and rovers, it is vital to monitor weather patterns there.
After the terrestrial planets come the gas giants, beginning with Jupiter, the largest planet in our solar system. From spectacular light shows at the poles to a comet's impact, Hubble has captured it all.
Have you ever seen Earth's magnificent northern or southern lights? All of the planets are subjected to solar wind, charged particles ejected from the Sun's atmosphere. When this wind collides with particles within the planet's magnetic field, they give off light, creating the familiar polar phenomenon. Using Hubble, astronomers have been able to capture the same spectacle on Jupiter. Hubble caught the evidence of comet Shoemaker-Levy's collision with Jupiter in the early 1990s. Seeing the aftermath of the impact in such detail offered a unique opportunity to witness this cosmic event without the danger of experiencing it on Earth.
Continuing its neighborhood watch, Hubble has also taken some breathtaking images of that wondrous ring planet, Saturn. Again, with its sharp eyes, it's been able to observe weather patterns on Saturn and see some of its moons.
Saturn's ring system is the largest one known in the solar system. Astronomers have long debated the origin of these rings. Hubble data have helped astronomers study the gas giant when the rings were at maximum tilt towards the Earth. Saturn experiences seasonal tilts away from and towards the Sun, much the same way as Earth does.
Of Saturn's 60 known moons, Titan is probably the most intriguing. That's because it's so similar to the Earth during one of its early phases of evolution, and because it's got an ice volcano.
In 1995, scientists from Arizona captured the first images of the surface of Saturn's giant, haze-shrouded moon, Titan. Hubble's groundbreaking observations helped set the stage for NASA ESA's Cassini mission, which sent the Huygens probe to the surface of Titan, giving us close-up images of this icy world.
Saturn isn't the only planet with a ring system. In fact, all of the giant planets have one. Hubble has produced one of the first images that revealed the angle of the tilt of Uranus's rings.
Hubble scientists were, for the first time with visible light, able to detect clouds and wind speeds in the northern hemisphere of Uranus. And Hubble data from Neptune have shown the planet's powerful equatorial jet stream, immense storms, and dark spot in its northern hemisphere.
In a way, our solar neighborhood changed in 2006, when one of our planetary neighbors, Pluto, was downgraded from a planet to a dwarf planet. When it's closest to Earth, Pluto is still a whopping 4.28 billion kilometers away. To give you an idea of how far that is, NASA's New Horizons spacecraft is currently on its way to Pluto, and it should arrive there in just about 9 years.
Using its advanced camera for surveys, Hubble gave us the clearest view yet of the distant dwarf planet Pluto and its moon Charon. In 2006, using the same camera, Hubble confirmed 2 additional dwarf planets, Ceres and Eris.
Well, it's good to know your neighbors. You never know, what happens to them could happen to us too. This is Dr. J, signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.